So again, we have a quadratic equation, and if we have a quadratic equation with a sine squared and a sine, or if you ever have an x squared and an x, you're going to make one side equal to 0 so you can factor and solve. This one's a little bit more difficult to factor just because that first number is a 6. If I try to do it directly to begin with, I don't know if I should put a 6 sign and a 1 sign or a 3 sign and a 2 sign. Right? Because our previous one was a 2 in front. It only had one option. So actually what I do with this one, again, I'm thinking about the fact that this will be my first one, these are my last one, then my outside and inside get combined. I actually look at my last one and see that it's a 1. The only whole numbers that are going to work there are 1 and 1. So I actually start with that because I know that has to be a 1 and a 1. And now when I'm thinking about my first one, should I use a 6 and a 1 or a 3 and a 2? Which of those two, when you think about your outside and inside, can make a possible 1, adding and subtracting? It has to be the 3 and the 2. So we write 3 sine theta and 2 sine theta. Now my outside would be 3 and my inside 2. If I need to be a positive 1, I would need my outside to be plus 3, my inside to be minus 2 to get that positive 1. So once again, what you're really doing if you're factoring directly is you're just thinking about how does foiling work and how do I undo it, and sort of working back and forth that way to find something that works. If you want to use a longer technique that you learned in grade 11, that's fine, or a technique you learned in grade 10. But for most of the ones in grade 12, you should be able to go directly to the factored form. They don't get too complicated that this method would take forever. So after you factored it, well, either this one's 0, in which case you get sine theta equals 1/3, or this one's 0, in which case you get sine theta is negative 1/2. This question, unlike the previous one, would be on the calculator part of your exam. And usually they say, put your answers as exact values where possible, or round to 3 decimal places. So are either of these on our pie plate? Yes, the second one is. What's your reference angle when sine is a half? Oh, 30 degrees, or pi over 6. Now again, we're in section E. If you go all the way back to A, the domain is in radians, so we're supposed to answer in radians. And since sine is negative, it would be in quadrants 3 and 4. So these are exact answers because we haven't rounded them. We kept them in terms of pi. But the other side here isn't on your unit circle. The y-coordinate's never 1/3. So then you have to go back to the same way you would have solved this in grade 11. You need to find your reference angle. How do you find your reference angle with your calculator? Sine inverse of positive 1/3. So I go to my calculator. Excuse me. Sine inverse of 1/3. Oh, I'm in degrees, so I have to make sure I change my mode, make sure it's in radians. 0.3398 to 3 decimal places would be 0.340. Should practice using approximation signs whenever we round. So then theta will be in quadrant 1, 0.340, and in quadrant 2, if I'm thinking about quadrant 2, in degrees I would do 180 minus my reference angle. So in radians I would do pi minus my reference angle. 2.802. If you rounded early on something, perhaps you did pi minus 0.34 instead of 3398. Oh, it would have still worked out, just barely. But if you had done 3.14 minus 0.34, you would have missed out on that third decimal place. If you round early and your final answer, the rounding is off, that is an E6 error for rounding. Okay. So this is the first one with calculator that comes up. Another one with calculator, I'm going to call this F. We're going to choose 2 cos squared theta plus 9 cos theta minus 1 equals 0. Okay. So, to start off on this one, if you tried to factor, okay, it should be 2 cos and cos, right? That would be the only possibility there. And 1 and 1. Do my outside and inside make 9 ever? No. So this can't be factored. What do you do when you can't factor a quadratic equation? Give up. Wonderful. What's that? The multiplication thing? How does that work? Oh, that completing the square thing? Yeah, that would work. Or the quadratic formula. Okay? So on your formula sheet, they give you the quadratic formula. A lot of grade 11 formulas they don't give you, which means you just have to have them memorized, or they won't ask questions. For this one, they give it to you, which they didn't at the beginning. This was added a couple of years ago after the new curriculum came in, because they're like, oh, if we give them this formula, then we can ask questions like this and not feel guilty. Now, the formula there says for ax squared plus bx plus c. A, b, and c are coefficients or constants. They're numbers. The x is the variable. But we don't have an x in our equation. What do we have? We have cos. So instead of x equals from your formula sheet, you would start off by writing cos equals negative b plus or minus b squared 81 minus 4, a is 2, c is negative 1, divided by 2 times a. And so if I simplify this, I get cos theta is negative 9 plus or minus 89 over 4, which technically gives us 2 different possibilities. We've got cos theta is negative 9 plus the square root of 89 over 4, and cos of theta is negative 9 minus the square root of 89 over 4. So we'll solve each of these separately. Now, the way the number looks right now, it's not easy to work with, so we're going to just change that to a decimal. Go to my fraction button, -9 plus the square root of 89 divided by 4, 0.108. And if I do the one with the minus, do you know the trick on your graphing calculator to retype something you had from before? There's two ways of doing it. One, you can go second enter, and it just pulls up what you typed before, which is really handy in this case because all I wanted to do was change that plus sign to a subtract sign. Or you can use, depending on your operating system, some of them you can just highlight by going up and clicking on them, like that. So I get -4.608. Now we can solve for theta. One of these we can do right away. Which one? I'll give you a hint. This one's not possible. That one's not possible because it's bigger than, it's -4. You would have to have your hypotenuse to be 1, your adjacent side to be 4. It's not possible. This side, however, does work. So we need to find our reference angle. We find our reference angle by doing cos inverse of our answer. Now, I wrote just 3 decimal places, but again, we need to keep all of our decimal places. So when I go cos inverse, I can either write my answer from before, or maybe I even select what I typed before. So I have all those right, and I find out that my reference angle is 1.462. Reference angles are always between, in degrees, 0 and 90 degrees. So reference angles in radians always have to be between 0 and half of pi. Or, if we wanted to use numbers, between 0 and what number? What is half of pi as a number? Is 1.46 bigger or smaller than pi over 2? It's smaller because pi over 2, if you took 3.14, cut it in half, you'd get about 1.57. So it's one of the things you should always be checking for your reference angle, that it's between 0 and 90 degrees or between 0 and 1.57. This is good. Now cos is positive here, so it will be in quadrant 1, 1.462, and quadrant 4. Quadrant 4, I would go 2 pi minus my reference angle, 4.821. So your final exam usually has 5 or 6 calculator questions. And this is a good candidate from this unit. 5 or 6 calculator questions.
How many total questions?
Usually about 40 to 50. Yeah.